Every time someone tells me WPF can't do modern animations without a third-party library, I want to show them this. 5 animated reaction buttons: hover up, lift, scale, tooltip fades, bar stretches, click squishes, and all these animations without 0 NuGet packages, 0 third-party libraries, pure WPF storyboards, and about 200 lines of XAML. Today, I'm going to show you exactly how I built it, and more importantly, why each piece works the way it does. By the end of this video, you will have a mental model for WPF animations that you can apply to your UI elements and build. Download link for the whole project is in the description, so let's get into it. Before we touch any of the code, I want to show you what we are converting. Here's the original HTML component from UIverse, and it is a Tailwind CSS pill with 5 emoji buttons. Each button has a hover translate Y, which lifts it up. Then we have the hover scale of 125. It scales it 1.25x, and the before pseudo classes that fades in as a tooltip. And the outer div has an hover scale of 105, which basically scales the complete outer division to 1.05x. In CSS, all of that is one line per effect because Tailwind abstracts the animation engine. In WPF, we do it explicitly, but the explicitness is actually a superpower because you have precise control over every keyframe, every easing curve, every target property. Here is the translation table that I have built while working on this project, and every Tailwind class maps to WPF concept. So let's go build this one by one. Here I have Visual Studio open, and I have created this WPF application targeting .NET 8, and I've named it WPF Reaction Bar. Our file structure is clean and intentional. No view models needed here. This is pure visual component work. No models, no third-party packages. That's it. That's the entire dependency list. Now you can see we have this folder called controls, and inside our controls I have created my user control over here, and I've called it ReactionButton.xaml. This is the core building block. And in our XAML reactionButton.xaml.cs, I have declared 2 dependency properties. If you can see over here, the first one is the emoji dependency property, and the next one is the label dependency property. So emoji basically drives the glyph icon, and the label drives the tooltip. Dependency properties are not regular C# properties because we want them to bind from XAML. Now on the reaction, now under the controls, you also have the XAML, the visual structure that has basically 2 rows. If you can see over here, I will scroll down and we'll come back to the resources later. But here you can see we have our grid, and it has these 2 rows. And the first row is the part tooltip that will house the tooltip, and a border that is invisible by default. So here we have our tooltip border, which is within the grid row of 0, and its opacity right now is 0, which we will trigger or change using animations. Then we have the next border, which is called part root, and which is the button circle, and this is housed within the grid row of 1, and it also has a corner radius of 22. Then let's move to the key architectural design. So if you see over here, within our border, we have this RenderTransform group, and we need these transforms on one element because we need scale and translate, and the WPF does not allow you to animate 2 separate render transforms. You can only set render transform once, so you use TransformGroup instead, and this gives you each transform a name. That name is what the storyboards target. And critically, if you see over here, we have the RenderTransformOrigin, which we have set to 0.5, 0.5 on the border. Without this, the scale grows from the top left corner. With it, the scale radiates from the center. Always set this when you are scaling UI elements. So if you want to understand what I mean, so for example, if I run this application now, and let me zoom in, and here you can see when I click on this, so it is scaling directly up and not from the top left corner. So if I let me run, close this and just comment this out for now. And let me run this application again, and let's wait for the application to load. And there you have it. And now when you see, it loads from to the top left corner, and here you can see. So here you can see the gap between the two other buttons, so it is not aligned to the center. So that is what the RenderTransformOrigin helps us on the border, and without this the scale grows from the top left corner, and with it radiates from the center. So always set this for scaling. If you need it to be from the top left corner, of course you don't have to set this, but if you need it from the center, you of course have to set this property. Next, the heart of this animation are the storyboards. So let me go back to the top, and here we have the storyboards. And if you look at this storyboard over here, we have the first storyboard, which is the hover in, and then on the bottom we have the hover out. So let's talk about the hover in storyboards. So this has 5 animations running in parallel. The first one targets the translate Y property. Then which lifts basically the element to -20, which is from the 0 to -20. So it lifts this circle up. And then we have the scale X and scale Y properties or animations that will scale our circle from 1 to 1.25. So basically when I click on this or hover on this, this circle will grow in size from 1 to 1.25x. So then we have the tooltip fade in, which changes the opacity of our tooltip from 0 to 1. Before this you saw that our tooltip opacity was 0, and now here using this animation we will change our tooltip from 0 to 1. And the same tooltip slide up, and here we slowly slide our tooltip from 0 to 6. Basically what happens is it changes the position of our tooltip. Then we move to our, and also notice that all of our storyboards animations have a duration of 0.0002, which basically eases our animation. And here you can see we are also using an easing function of smooth ease. So all these animations will be smooth. So now if I go to the hover out section, the hover out sections are exactly the same, but here if you see, we are just switching the values back to the default. So from 1, we are moving the value back to the default, which is 0, and all these scales are set to 1 from 1.25. And this is basically the hover out section. And now we will move to the ClickPop storyboards. So basically the ClickPop storyboards will add an extra flair to our animations. So if I run the application now, what you will see is this animation that is triggered when I hover in and hover out. Also when I click on the hovered animation, so you can see it just pops. Right now it is not centered. That is because I forgot to remove the or uncomment the border render transform origin. Let me uncomment it and run it again. And now when you see the click, you'll see that it pops. It changes the scale from 0 to 1 and 1 to 0. So let me stop this, and this is basically what it does. So if I go back to the storyboard animations for the click pop, you will see we have 3 keyframe animations, 1, 2, and 3. The squish keyframe, for example, over here uses the BackEase easing function and the amplitude of 0.5 that slightly overshoots, gives its springy physical feel. The HTML original doesn't give this, and it's an enhancement that feels right for our native Windows app. Next, we will wire these using triggers. Event triggers in XAML fire storyboards when routed event occurs. No code behind. The storyboard targets named elements, part scale, part translate, part tooltip by their x:name. So now let's move to our MainWindow.xaml. This is where the outer bar lives. So let me go to Solution Explorer and open our MainWindow.xaml. And The pill is a border with corner radius of 32. So let me go to the top, and here you can see we have our border, and it is having a corner radius of 40, and we have set a border of dark gray, and inside this we are housing a stack panel, and this stack panel has 5 reaction buttons. So here is our like button, cheer, celebrate, appreciate, and smile. These are the user controls that we are tying it up with our window. So this control prefix that you see over here is basically referencing the namespace over here, which is our controls namespace, and this user control lives within our controls folder. So that is how we are referencing it into our window, and we have our 4 or 5 reaction buttons within our stack panel. We also see that we have a margin of 4 to the left for the gap and the spacing. The bar level animation, that is the hover scale X105 from the original CSS, is in the MainWindow.xaml resources. So if I go to the resources over here, window.resources, you can see the whole bar will scale 1 to 1.05 on mouse enter, and will scale back to 1 after the mouse leaves. So here is the storyboard for that, for the bar scale in, which is a double animation, and we have the bar scale out, which is also a double animation, which will change the value back to 1, and it is using the easing function to smooth all this animation. Also notice that we are using the render transform even here, just like we did on the reaction button, which is over here, which ScaleTransform, which basically anchors the whole animation of this outer bar pill from the center. So without that, it will slightly skew to the top right corner, and the animation won't look good. Also, you can see, like I explained, we have our 5 emoji buttons, and these are the 5 lines for our user controls. Finally, we have to just hit F5 on your keyboard, and let's see this in action. So like I showed you in the starting of this video, the demo, where we have our animation, and you can see when I hover over the pill, it slightly scales to a bigger size, and when I hover out, it goes back to normal. The same with the buttons or the emoji user controls, which changes their position and size based on the animation and storyboards that are triggered. And finally, when I click on one, it uses this ClickPop double animation to animate the size of this circle or the button. So all of that is WPF Storyboards. No third-party library, no animation framework, just the platform doing what it is built to do. 5 takeaways from today's video. When you need to scale and translate one element, put both inside a transform group and give each a name. Storyboards target the name, not the element. Second is the RenderTransformOrigin set to 0.5, 0.5 always. When you forget this and your animation scale and jumps to the corner, set it on every element you are scaling and rotating. 3 is to use easing functions. Spend 10 minutes in Blend Easing Editor. It pays off on every animation you ever write. 4 is pseudo elements. The CSS before and after have no WPF equivalent. Make them real borders or text blocks, set them invisible by default, and animate them in. It's more verbose but also more debuggable. 5, zero code behind for visual animations. If you find yourself writing animation logic in C#, stop and ask whether a storyboard in XAML can do it. 9 times out of 10 it can, and it keeps your code behind clean. Here's a question for you. What's the most complex animation you have built in WPF or tried to build and gave up on? Drop it in the comments. I read every one, and it helps me pick the next topic for my next video. If this was useful, subscribe. I post WPF and .NET UI tutorials every week, all native, no third-party libraries required. Hit the bell icon so you don't miss the next one. Till then, bye-bye.